Good morning, y'all, and welcome to the stream. Good morning, everybody. I'm here. Today we got a lot planned for calculus. A little bit for stats, but calculus is really the main point today because I have my exam on Monday at 8 a.m. So I gotta get through today and tomorrow quite a bit of studying. So yeah, that's gonna be the plan. Let me just pull up my flashcards here, and then I will switch over to them just like that. All right, and we begin. Let the series let Fn be a series of a sequence of real functions. Let f be a real function. Then we say that the sequence of functions Fn is uniformly Cauchy if the the sup norm of Fn minus Fm goes to 0 as n and m go to infinity. Ooh. There we go. And that one's correct. Alright, next we have let Gn be differentiable and let x null be an AP. So then what would imply that it's that the sum is differentiable and that the derivative of the sum is equal to the sum of the derivative? I think the sum of Gn prime needs to converge uniformly, I think. And I think also the sum of Gn of x null needs to converge to a finite value. Sum of Gn prime needs to be needs to converge uniformly, and the sum of Gn of x null needs to converge to a finite value, and that's what it'll tell us that. So that is correct. Took me a minute there though. So let f be a what is that called? Or what would I even call that? Like a power series. Wow, it is. My morning times are not the best. Okay, here we go. Let's do this. So we have f being a power series with a positive radius of convergence, with a non-zero. That's what it's positive, but like basically what matters is that it's non-zero, because by definition it has to be positive, or has to be non-negative. So then we can say that the integral from x null to x of f of s ds is equal to the sum from n equals 0 to infinity of a sub n over n plus 1 times x minus x naught to the n plus 1th power. And that will have the same radius of convergence. What? There we go. So same radius. Okay, this is something I just noticed, is that it looks like even though it shows up like as display style here, I don't think it does here, so I think I have to actually put in in order for it to look like that. So I'm going to go ahead and do that. That just basically has to do with whether or not the lines have to, whether or not it squishes it, so that way it stays in line, or whether it lets the sum become like big. Displaced. Okay, there we go. Close. So you can see now, you can see this is boom. So that's a lot better. The same radius of convert it. So I got that one correct, by the way. Which means I'm done with it for right now. Okay, because we'll go back through this. I'm never going to run out. Okay, so let g be a real function. Then the sup norm of g is defined as the supremum of x in E of, or sorry, the supremum such that x is in E of g of x, or of the absolute value of g of x, I should say. Yep. Okay, so we have fn and f both being integrable, and something else. So we have it being uniformly bounded, so I just think we need pointwise convergence. So I say with fn converges pointwise to f on AB. That's correct. For a power series, oh, I have to wait till this expands, but afterwards I want to fix that. For a power series with a positive radius of convergence, it diverges for all x where the absolute value of x minus x naught is greater than r. Yes. Correct. Okay, so now we have let fn, capital Fn, I should say, be differentiable on AB and x naught be a point on AB. Then we can say that I actually don't know what would imply that. So fn prime needs to converge uniformly to lowercase f on AB, and have fn of x naught converge to some point A. Okay. So we're gonna try that one again. Let fn be a series of functions, a series of real functions, and f be a real function. Then we say that fn converges to f on E with respect to sup norm if the sup norm of fn minus f goes to 0 for the sup norm of fn minus f goes to 0 as n approaches infinity. Yes, correct. Okay, now we got let fn be... Okay, so this was the same one we were doing earlier. So we need that capital Fn prime converges uniformly to capital Fn prime converges uniformly to... Oh wait, hold on. There's something I want to mess with. I think I messed up for this thing because there was this image occlusion. Is there not a way for me to make this... Yeah, just give me just a second here. I want to do something real quick with that. I'm just adding a tag because there were certain things that were not added to the correct tag here. So... It says no notes have been updated. Wait, can you not add? Is there not a way to do that then? Okay, give me just a second. What if I instead go back to this? Let's say I reconstruct this. Options, here we go. So we got... I don't think we need... I think it's or by default. I think you have to put and if you want the things to be. Or no. How do you do... I actually don't know how the how that works on here. Let me see. Give me a second. Anki manual personal revision. Or sorry, custom study. Filtered decks, that's what I'm looking for. Custom study session. Look, we have searching. Is there a way to do type? So we have tags. Oh, here we go. So it would be note. Oh wait, you guys can't see that. Sorry about that. I forgot to switch back here. So I'm looking for the note to be not basic. I want it to be so basic was one of the options, but that's not what I'm looking for. So I want basically I want this one, this image occlusion. Notes. How do I do this? Info. Oh wait, is this already in here? Like if I have this set? Oh, these are already here. So they already have that tag. Oh, okay, never mind. So I think we should be fine on that front. Oh, well, I don't think I needed to remove all my things I just scheduled, so I think I just screwed up there. Oops. That's me. Might be. Okay, so I guess we're starting over. Let Fn and F be Riemann integrable, and Fn converges pointwise to F on AB with Fn being uniformly bounded. That's what it was. Okay, for a power series, that with the radius of conversion is blank. What does it do for all x where x... Oh, this is the thing where it's like super convergent, where it's like uniformly, absolutely convergent, I think is how you're supposed to say it. Is uniformly absolutely convergent from all, yeah. Okay. Let Fn functions, and then we say that this if for all x and for all epsilon. I think this would be pointwise convergence. Yes. Good. Okay, so let f of x be defined as a power series with a positive radius of convergence. Then I can say that... Oh, this is the Taylor series thing. I think that we say that f is... I don't remember. Infinitely convergent on that thing. Okay, so let me put in a little hint, because that's something you can do. I don't know if you guys knew this, but you can actually add in... Oh wait, what did I just do? Oh, you can't Okay. Nice. Nice work, me. Here we go. So I think the idea is that f is... Yes, that's what it is. And then I can just, yeah, add this. And then I think if I just do this, then test, yeah, I think that's how that works. So, but I think I need this to be LaTeX, so I'll just put in text. Hello. Wait, why did that not work? Oh, that's fine. That's why that didn't work. So something like that. So what would this look like? Oh, and then I can do something similar here. Because I just think that, like, otherwise we're just left with this, like, really awkward thing where it's not really even a task of figuring out the truth. It's just kind of weird. So let's put this here. Okay. Well, actually, hold on. We don't even need the hint. what I could do instead is just move this opening part to be after this. We'd say a sub n equals and then that. Yeah, I think so. I think that's good. There's C2, but there's no C1. There should be C1, sorry. Cross. Default. Okay. Here we are. For a power series with a radius of convergence, with a positive radius of convergence, it converges uniformly, is what I would be able to say, I think. For all x, where, yeah. Nope, absolutely. Dang. Okay. If Fn converges to F uniformly, what other thing would I need in order to say that F is continuous? Oh, that Fn is continuous? On E? Yeah. That's uniform continuity. Right. Okay. Let Gn be differentiable and X not be. And Gn prime being uniformly what do you call it? Uniformly convergent on AB, and Gn of X, or sum of Gn of X not converging to a finite value implies that, oh shoot, I knew that there's like three things. So one of them is that the the derivative of the sum is equal to the sum of the derivative of Gn. And I think, was that it? No, I feel like there was more to it than that. Let me see, because I don't remember anything else. There was more to it. Oh, that it's differentiable. Well, that's implied by saying that it has a derivative there, but I'm still not going to count that. I need to remember that part of the definition. Right, power series with a positive radius of convergence, it converges absolutely for all x where the absolute value of x minus x naught is less than r. Correct. Okay, all we need here is that Fn and F are integrable on AV. For a power series, the radius of convergence r greater than 0. That one's pretty easy. Alright, it's been around 20 minutes, so I might say we stop here, at least for the moment. And now, we move on from that to actual working on problems. But first, before I do that, I have to very quickly grab my stylus. Or, well, I have the stylus for it, but I need to grab the drawing tablet that goes along with it, so that way I can write my answers. But I'm gonna go over some problems then. Alright, so give me just a second. I will be right back. Listen to some tunes while you wait. And we're back. I got my drawing tablet with me, my Wacom Intuos something or another. It's whatever the smallest size is for the drawing tablets. It was, I feel like it was like $30 or something, which, I don't know, I've gotten a decent amount of use at it, so I think it was definitely worth it for me. I know some people get like a tablet, but for me, I really prefer the drawing tablets, because if I have my hand resting on it, it doesn't screw it up the way that it does if you do that with an iPad or whatever. Okay. So let me go ahead and synchronize that. Okay. Let's open this up. And then I was going to go over my homework 8. Because I think I got like a 50 on it. So I'm going to go through these questions one by one and then see what the actual solutions were. Because yeah, I got a 48 out of 95, which is, so yeah, I got a 50 almost exactly. Below a 50. Not good. So we'll go homework 8. Here we go. Wait, there was a homework 9? Okay, well, I'll have to go through homework 8 and 9 then. Dang. Okay. So I might do homework 8 and 9 today then. So give me just a second while I do this. There we go. Okay. Oh, you guys can't see this. Hold on. Let's switch this over so you guys can. Although, actually, to be fair, if we're doing this, I should change this so that it's a window capture instead. Alright. That should be more correct. Otherwise, it's stretched for you guys. And you can see a little black border at the bottom, but that's okay. There we go. Oh, I should change my title here. Give me a second. There we go. That should be saved. And we're on to the next. Okay. Alright, here we go. So we are starting with the fact fn converges to this on that. We have that f of x, and f of x is its pointwise limit. Okay. So we know, we know that fn converges to f on 1, 0, 1. So that's one of the things we know. Okay, so we're supposed to use supernorm convergence. So if we remember by the definition of supernorm convergence, that says that. So let's go ahead and start with these. Basically, we want to say that as n approaches infinity, the sup norm needs to approach 0. So let's say, so we'll start with the sup norm of f minus. of f n minus f is equal to, oh well, actually hold on, let me move this down so it's not as big. Let's also zoom in a little bit. Yeah, maybe that amount might be a little bit better. And then we move back over, so we're like this. There we go, that should be better. So we know that fn converges to f on 0, 1. And so then let's do this. We'll take the sup norm of fn minus f. That is equal to the supremum such that x is in 0, 1 of the absolute value of x n over 1 plus xn. So it's 0 for that, and it's 1/2 for x equals 1. Let's say minus f of x. Okay, so is there a way to prove or to figure out which one would be the supremum here? Because I think so we have two possibilities. So our first one, we're going to take x in 0, 1. Alright, then what we're left with is the supremum of f n minus f is equal to the supremum of x in 0, 1 of xn over 1 plus xn. Which would give me does the supremum actually have to be in the interval? I don't remember. I think it does. Does the supremum just have to be a limit point, or does it actually have to be in the interval? Okay, this is really loud. Can we turn this down? That might have been quieter. I can't tell, to be honest. Oh, that's not what I meant to do. There we go. There we go. Okay. Wait, hold on. Can you guys not see what's going on at all? Oh no, you can. We're good. Sorry, so the supremum just I think the supremum just has to be a limit point, right? If I'm not mistaken. Or is the supremum... Wait, what is the definition of a supremum? Is the least upper bound of the set. So the smallest number that is greater than or equal to every number in the set. So it's necessarily is equal to, what would be this? Which would be, oh no, we're supposed to be showing it that it does it for all delta. Sorry, I wasn't even paying attention here. Okay, we don't need the two possibilities or whatever. Yeah, what I was trying to show. Sorry, 0 to delta of this, which is equal to the supremum for x and 0 delta of x n 1 plus x n which equals, nope, I did that the wrong way around, which equals delta to the n over 1 plus x, or sorry, not x, 1 plus delta to the n. Which tends to, what does that tend to? That should tend to 0, or right? Because this will tend to... Because each of these would tend to 0, right? At the same rate. So we'd end up with like 0 over 1, I think is how that would work. Which tends to 0 as n goes to infinity. Thus, by definition of sup norm convergence, Fn converges uniformly to F on 0 delta. Let's just put in oh, sorry, that shouldn't be. There we go. That's better. Okay, no, I think that should be the end of that proof. So this one's actually pretty simple to prove, I think. So yeah, we'll take that for sure. Alright, next up we have Part B. Let's see what that's like. Alright. Same deal. We'll do a new one. I just need to copy. Then paste. Oh, nope. Paste here. Let's put it here. need to erase this little thing. Okay. Anyways, so now we're supposed to use the supernorm convergence to show that Fn does not do that on 0, 1, which we know that. Alright. Wait, hold on. How do we use supernorm convergence to show this? I'm actually not sure. Okay, so let's just start with like the basic definition. So we'd say it's the supremum such that x is in 0, 1 of the absolute value of Fn of x minus f of x. Because I know that it isn't uniformly convergent. But how do I show that with supernorm? What I'm saying there is that the supremum of that is not 0. Which isn't that true though? I feel like that is true. Just a second. Let's just try to do it out if we end up with 1, right? What would I end up with here? 1 to the n minus 1 minus 1 to the n. There would be 2 times 1 over 2. Equals the absolute value of 1 to the n minus 1 over 2. Equals 0. So that's not what the problem was. Alright, I'm gonna see the solution, because that is available for this. I do have access to it. So let me see what I'm doing wrong here, because I am doing something wrong. Okay, it suffices to show that it doesn't on... Oh. I see. So that's not what the issue was. I was completely wrong about this. This one. So. Yep, that was a dead end. So instead what we do is we say, I'm going to put this in actually, hold on. Why did I erase that? I don't want to erase that. So let's just X that out so we can know that this was incorrect. Instead, what we're supposed to do is show that it fails on okay. So we just do fn minus f on 0, 1. Yeah, so I still don't know. Okay, so that's going to be the supremum for x in 0, 1 of the absolute value of xn over 1 plus xn. Which by definition is greater than or equal to the absolute value of xn over 1 plus xn on or sorry, we should say for all x in 0, 1. Ah, I see. So then now, so this is what we're left with here. So then now we say, what is the limit? Oh, sorry, this is messed up. What is the limit as... Sorry. As x approaches 1 from the left, of xn we end up with the limit as x approaches 1 from the left of xn over 1 plus xn. Which is equal to 1/2. Or sorry, we should say I don't... Shouldn't this... But we're missing a second one. Shouldn't it be the limit of the limit? Would this be like a double limit? We'd say the limit as n to infinity of the limit as x goes to 1 from the left of xn over 1 plus xn, which equals 1/2, not equal 0, which is greater than, or sorry, we don't care that's greater than, which is not equal 0. No, we do care it's greater than 0. Sorry. So we know that the we know the subnorm of fn minus f on 0. Oh, sorry, it's gotten tilted for some reason here. So my text started getting tilted there. My drawing tablet got tilted there. Oh, now it's tilted again. What the heck? On 0... on... Why can't... Okay, sorry. There we go. Sort of. Or sorry, we should say which does not go to 0. We don't say it does not equal 0 because we're saying we're taking the limit of that. Which does not go to 0. Therefore, Fn does not converge uniformly to f on 0, 1. There we go. Okay. That's what I'd end up with that one. Okay, now we're on part C. I'm supposed to use uniform convergence and continuity. There we go. C. There we go. Copy. Paste. See that here. There we go. It's supposed to use uniform convergence and continuity to show that Fn does not converge. So uniform convergence and uniform continuity. So uniform continuity states that if we have that Fn is continuous, sorry, that should be a C, is continuous on 0, 1, and Fn converges uniformly to f on 0, 1, implies that f is continuous on 0, 1. So, what we're saying here is that, so we're saying basically premise A is true and the conclusion is false, therefore, this is a statement of the theorem, right? The theorem states that if Fn is continuous and Fn converges to f uniformly, then f should also be continuous. So the fact that Fn is continuous, and f is not continuous, is telling us, we're taking the, what is that called? The contraposition. We're doing basically a proof by contraposition. So it's not a proof by contraposition, but we are using contraposition to show it basically. So the theorem states that this and this implies, and so we're saying, hey, we know that this is not true, but this is, so this can't also be true because otherwise it would break the theorem. So this has to be false necessarily. So we show, so basically all we have to do is use the fact, okay, that is nice. So we can say, we just have to prove that for all n we just have to prove that this is continuous, basically, on 0, 1. Right? So is fn continuous on 0, 1? So here we go. So the way that we do this is we say, or sorry, so we can, let's go ahead and select that here. Give me a second. And then let's move that over here. Okay. There we go. Good. Alright, so we're going to start off with let n in, let n be a natural number. So we're saying we want a generic n, right? Alright. Then we need to prove that it's continuous, and we have to use the definition of continuity. So we have to just basically all we have to do is show that fn is continuous, right? And so in order to show that it's continuous, we need to say that we need to use the delta epsilon definition. So we can say we'll say let epsilon greater than 0 and we needed a delta here. Then what we want to say is that there exists a delta. Wait, no, I don't remember the delta epsilon definition of continuity. Delta epsilon continuity. Dang it. So we'd say, so let epsilon be greater than 0, then we would need to show that there exists some delta greater than 0 such that f minus, or sorry, we should say, that should be f, sorry, that should be let x naught 1, I want to show that there exists some delta such that, or sorry, x minus x naught being less than delta implies that f of x minus f of x naught is less than epsilon. That's what I'm saying. So then now, to do this, we just need to say I never learned how to do delta epsilon definition of the limit. I only learned how to do it with sequences. The capital N one. I never learned how to do it with functions, so unfortunately I have a little bit of issues with this. So let's take this. F of f sub n of x equals, so we're saying x minus x naught needs to be less than some delta, needs to imply, well, how do we show that? I actually don't know how to do this one at all, which is worrying that I don't know how to do any of these damn questions. Oh, well, so this just asserts that it's continuous. This just asserts, hey, f is continuous, but I don't think it says that. It just says that it equals this. So why is... What am I missing? Why wouldn't that be, why would that be continuous necessarily? So we have x over 1 plus x, which gives us a so we'd only have one discontinuity, which would be at, okay, so yeah, okay, so instead of trying to formally prove it, let me just say this, okay, alright, looking at fn of x, there's a discontinuity discontinuous only, sorry, at 1 plus x to the n equals 0, which is to say, which says that x to the n equals -1. Which is impossible, or sorry, which has no solution on 0, 1. Because x to the 0 is 1. We're never getting anything under 1. I actually don't even think that this is possible. Does that even ever have a solution? I don't think you can, I guess it depends. No, it could have a solution if x could be outside, right? Because if x could be -1 and then n was 1, then that would have a solution, right? Okay, but looking at fn of x equals -1, but that has no solution on, sorry, on x in 0, 1. Thus, fn is continuous on 0, 1. but f is not continuous on 0, 1. Thus, by uniform continuity, I think that's what I have to say, right? Yep. All right. All right, that's 8. Okay, so that's number 1. That's question 1. All right, we're on to question number 2. Let's do this. Let's do it. Boom. Copy. Paste. All right, here we go. All right. Let fn be x cosine nx on R and fx be 0 on its pointwise limit. We need to show that fn converges uniformly to 0 on RR for all r greater than 0. Alright, so let's just get started by doing it this way. The sup norm of f n, so the sup norm of fn minus f on which is equal to okay, let me see. Must it necessary? So I'm trying to think. On RR, is it possible that we could ever have it being, because my first thought here would be that we would end up with no, I don't think so. I think what we'd end up with is that this needs to be less than or equal to Rn. Because we're talking about the absolute value of the cosine. And so that would be the maximum that could be, would be whatever value you could ever have, where imagine that R was such that cosine of nx is a local maximum, basically. So you're dealing with this would be equal to 1. So then you'd end up with x over n, but we're talking about R being that. So we'd say this is necessarily going to be less than R over n. Less than or equal to. Like at maximum, it could be that. and r over n goes to 0 on, let me see, nobody, okay, we're good. And Rn goes to 0 as n goes to infinity. Sorry, so thus Fn does converge to F1. Okay. Okay. All right, next. That was part A. That one was not too bad. Just a second. Okay. Oh, I pressed the wrong button. B. Okay. All right. So I'm supposed to use soup norm convergence to show that Fn does not converge. Okay. Yes, I got it. So, take any as shown in part A. Oh. As shown in part A, the soup norm of Fn minus F on negative R to R is equal, or sorry, is less than or equal to R over N. Basically what I want to show is whatever try to limit you can come, you create a new limit instead. I want to show that it's not bounded. Is the way that makes sense to me. As shown in A, Fn minus F on, for all of that is less than r over n. Sorry. We could say that there exists some n greater than n, or sorry, some new r, or sorry, I probably shouldn't use that symbol. Exists some row, maybe we'll say, some row greater than r such that rho times cosine in rho over, what was it? Over n? Always. Yeah. That there must exist some things, that way equals whatever, which we need to state is greater than r over n. Thus, fn minus f has no upper bound. Or sorry, I should, instead of saying that, what I should say is that fn minus f has no upper bound. Thus, the supremum such that x in r of f n of x minus f of x equals infinity, not equal to 0. Thus, fn does not converge uniformly to f on the real numbers. That would be my argument, but let me see what the solution is, see whether it agrees with me. Okay, this one, it specifies the kpi thing. So, yeah, okay. I don't know whether I have to, okay. Okay, so the only thing that would be done probably to correct this one would be to have the same thing, except for we would instead of saying there exists a row in R, we would instead say that exists a row in the natural numbers such that, or sorry, we'd instead say let row greater than r, or sorry, row in the natural numbers such that row n greater than r, sorry, row times, sorry, such that pi row is greater than r. And then we end up with pi row cosine of pi n row over n equals pi row over n greater than r over n. So that would be the one difference, is that we'd basically specify which thing, right, we're talking about. So we'd specify, hey, here I'm talking about, yeah, when would that happen? And so the answer is every pi. Makes sense. Or, well, so, sorry. Well, we'd say the absolute value is equal to this. I want to be clear. Yeah. Is equal to pi row, yeah. I have to be clear, because otherwise it's negative, and that's not what I'm looking for. Thus, that has no upper bound. Thus, the supremum of that is equal to infinity, which is not 0. Thus, it does not converge uniformly. Okay, otherwise, all good on that one. Okay, and then now we have part C for homework 8. We're supposed to use uniform convergence and boundedness. Got it. For this third one. Give me a second so I can screen cap this. Let's do that. Boop. Boom. There we go. Alright. Here we go. Oops, sorry, that was the wrong. I just accidentally snipped the wrong thing there. Give me a second. Give me 1 second. Okay. Copy that. Paste this. There we go. Okay. Now, I'm supposed to use uniform convergence and boundedness to show that this is not the case. So for this one states that Fn being bounded on R, and you need that Fn is bounded and Fn converges uniformly to F on R, implies that F is bounded. So we just need to show, for this one it's super easy. We showed that we showed in part B that, oh, music keeps stopping. Okay. We showed in part B that, that Fn or sorry, we should say that the absolute value of Fn is unbounded. Well, actually, I think we need to do this one separately. It's basically the same deal, okay? All right. Take our... we basically need to do the same thing, but instead we're doing it with... instead, it can't be absolute value. It needs to be the actual thing. So we'll say take r in the real numbers, okay? Then we got by part A, or no, okay. I think we just end up with 0 to r, right? Basically, what I want to say is that is majorized or bounded above by r over n. So we have that that's the case, and then we have basically that take rho in some natural number rho such that rho times, sorry, such that 2 pi times rho is greater than r. Then f sub n of rho, or sorry, of 2 pi, sorry, that should be pi, 2 pi times rho equals 2 pi rho cosine of n 2 pi rho over n, which is equal to 2 pi rho over n, which is greater than r over n. Thus, Fn is not bounded in R. It's not bounded in R. But f bounded in R. So Fn does not converge uniformly to 0. On R. There we go. Shit, I just dropped my fucking stylus there on the ground. Dang it. What the hell? What happened there? Oh, there it is. It's this part of the floor. But 0 is bounded in R, so Fn converges uniformly to... Sorry. So Fn cannot converge. Sorry, I forgot to put this part in. The only part that I kind of skipped around with was this, but I think this is pretty obvious. I don't know. Maybe it's not. I think it is, necessarily. I don't think it's obvious, but it definitely is the case. I don't know. It's obvious to me, but maybe he'd make me show it. I'm not sure. If he did, I might have a little bit of trouble. But it's like kind of bounded. However, oh, okay. Okay. I think I might stop there possibly for the moment. I don't know. At the very least, I need to take a break from working on the calculus because my brain's starting to fry a little bit. Which is not a good sign necessarily for the test since it'll be at least that long. But yeah, I just need a break here for a second. Okay. So, what else do I got going on? I guess I'm just kind of chilling at the moment, taking a quick break. So, if there's anybody lurking in the chat, go ahead and drop something. See if you have any questions or anything you guys are looking for. Actually, it doesn't look like I have any concurrent viewers at the moment. At the moment. But that's alright. What else am I doing then? Look at me. I mean, I guess I have some other stuff that I gotta get done. I guess right now I need to keep working on making my study plan here. So I guess I could work on that for a few minutes. I need to make my study plan for stats, because I do not have one. And it is very important to have one, so... Or I say study plan, it's a, it's more like a project plan. Like I have to complete a whole project, and I don't have... Or I don't know what I'm going to be doing in order to get it done. So I want to pull up the, what do you call it, instructions for it, so I can see the final project. Okay, the project guidelines. The final project is for you to find an interesting data set and formulate a question that you hope to answer using techniques from this course. Your deliverables will be 1, a report documenting your questions of interest, data, and results, and 2, a short 10 to 15 minute presentation, 10 to 15 minutes, describing your project. The presentations will be video recorded and uploaded to Canvas on discussion boards. They'll be so that they will be viewable by the entire class. Everything, including the video upload, is to be completed and submitted by no later than Friday, December the 13th at 2:30. The data will ideally be something of interest to you. Own room be publicly available, or you could do it. And I did do that. I did collect my own data, and it was a lot more work than I thought it would be. Dataset can be one that you have used for another purpose previously, but the analysis of it... Okay, I just don't care. You can work by yourself in a pair, group 3. Okay, that's not what I'm looking for. Report organization. Your report should consist of the following sections. So maybe I can start outlining my report. So maybe I could say outlining stats report. I'm changing my title on YouTube. Outline stats report. Okay, I'm gonna go ahead and open up RStudio because I think I'm gonna do it in R Markdown. Makes the most sense to me. Like if I'm thinking about that. So give me just a second to pull that up, and then I should be able to cue you guys in. So go to Files, Final Project. Yes, let's do this, and then we're going to set as working directory. Okay. Now that I've gotten that out of the way, I should be able to share screen with you guys. Can you... Does this... I don't understand why certain windows, it just does not want to capture. I guess I could do this, but this is not... Okay. Here we go. There we go. Okay. So we're working in R here. So let's do a new thing that's going to be an R Markdown doc. Final project report. R Markdown. Okay. So I'll replace this with my actual personal information later at the end, but I'm keeping it like this for the moment. And then I think its output is PDF. But actually, I don't think I should. It should not by default be set to that because I don't have LaTeX installed on my computer. I don't have it installed on my PC, I don't think. I only have it installed on my laptop, which I can't stream on, so... Or well, I probably could, but it would be trash stream, so... Let's try this. Oh, knit unsafe, let's see. So instead I want this to knit as HTML for the moment, and then it should... That should be fine. So let's see. Boop. Alright, so that did work. Okay. So let's see what kind of sections. I'm going back here. It says we got sections. I'm just basically copy pasting the directions here. Save. Let's see. Okay, introduction. This section will give a brief introduction to the problem, including a description of data and questions you have to answer. In the exploratory data analysis, create any graphs or tables you find helpful. Okay, so we have 1, 2, 3, 4, 5, 6. Okay, so let's do, I think for today I also want to do exploratory data analysis. So let's work on that then. Okay. Also potentially the demographics of your sample. So hold on, give me just a second here to, let me take in. Oh my gosh. And then I should be able to take this. See if this works. Please work. Okay. Okay, ignore this part. So this is the data we have. Okay, there we go. I think that's what it would be. So this is probably what I want to do. I want to look at these observations and then just basically look at some of these. I think what makes the most sense to me is to do, hey brother, I'm studying group theory. Oh, nice. And what class is this? At the moment that I'm working on, the class I'm working on is statistics for science and engineering 2. That's the class I'm in. And But yeah, thanks for joining. So after collecting all the data, I was left with this this number of observations of individual maps. So that tells me I got sorry. So I'm left with that number of observations. Each observation. So we should probably do a breakdown of these. Sorry. We'll say, or maybe we could say, here is the breakdown of observations by type of series. And then we can go ahead and create a quick R plot. Where we say, let's take, I think what I'd want here is a and then our x would be CS. I guess we'd probably say because basically what I want here is a bar graph, like so here's a breakdown of observations by type of series. So we'd say, I think it's called BO is the name of the variable. Let's see what happens if I try to do that. Will that work? Okay, so that does not give me what I want. Okay, I don't actually remember how to do a bar graph, so let me look that up. Bar graph in R. Bar chart, I should say. It should be called bar plot. Okay. Let's see, does that work? Uh-oh. Yep, that's not what I'm looking for. Oh, so this is taking those as numeric, but I don't want them as numeric. Those should be, I should be taking those as factors, which is kind of annoying. How do I get that? How do I get it to do that? I think this has to do with knowing reads this function. Can I take something as factor? We have strings as factor. How to convert a numeric to categorical in R. So then maybe we would say Does that work? Nope. Okay. This says height has to be a vector or a matrix. Okay, would I put in this maybe? I actually do not know how to turn this into a factor. Okay, here's a Stack Overflow thing. Should be good for this. Okay, my data has 8 variables and one of them is categorical, but R thinks it's integers, zeros, and ones. How do I convert it? Ah, I see. So apparently what I'm supposed to do is back here, I'm supposed to go I think that's what I'm supposed to do. Like that. How about now? I just basically want a thing of the number, right? Of each. Yes, exactly. Oh, so this is what I want. So I just do normal plot and it does that. That's basically what I wanted to do. I wanted to show that the vast majority of my maps were from Best of 3 series. Okay. So so we would say this, and then we can like, I can mess around with making it like look nice. I mean like add in a little title saying but I can do that. Obviously I need to, I'm going to rephrase this, but this is just like the outline. This is just like my first run through. So I'm going to do this even if it's kind of a little bit repetitive the way that I'm phrasing this. Here is the breakdown of observations by type of, by event. And so we do something very similar. And I imagine, we already have strings as factors, so this should be, we should just be able to do this one directly. PO. This should be very fast. So we're working with a what was it? Event, I think was the name of the give me a second. Let me pull up the data. I can't remember what was the name of these things. It was, yeah, event was the name of the thing. Okay, so let's try this. Let's see how that goes. So that should there we go. Okay, so those are some things I kind of wanted to include. So I just basically want to do some like basic like level 1 stats where we're talking about like instead of analyzing, we're just basically saying, hey, there's this many of this, that many of that type of thing. So that way there's like just an idea of that kind of thing. So we're dealing with that. Oh, that's also worth finding out. So we'll just do this with a bunch of this. Is the breakdown. We could say yeah, I think that those are all the bar charts that would work for this. But I think I think that there would definitely be more than just that. What other types of things? So any kind of correlations, scatter plots, box plots, etc. Summary information about the demographics. Okay. There we go. I feel like there has to be a way to change like the names of the factors. How to change names of factors in R. Just Google that. Apparently I can do that directly. You can use the levels function apparently. For the factor method. Oh, okay. So here we go. So I think the way that I would do this is we go back here, we get, you know what, I'm gonna get rid of this. We're gonna add that back in later, but right now I'm just doing this. So let's say levels. This, right? There we go. Let's see what we're left with here. 1, 3, and 5. So here we go. So we'd say levels. I don't know whether that should be like this. Sorry, that should be a string. Like that. Good. Should be best of 1. Okay. I should basically be able to do that with all these. There we go. Alright, let's test, see whether that works. Let's see. Uh-oh. So that did not work. It just created new factors? That's weird. Because... Weird. So should this actually instead be... Is the problem that I'm using single quotes? I didn't think that mattered, but maybe that's what it is. Or maybe I'm not supposed to use quotation marks at all for this part. Let's see. Let's see. I feel like it could be that. Okay, so it's not that. Okay, I think maybe the problem is that this isn't supposed to be a string at all. Let's try this. Maybe. Oh, we're close. Oh, I see. This should be 1, 2, 3. I see. Those were previously the values, but that's not the way that it works. So here we go. Yes, perfect. Perfect. So I think I can do something similar with mistake levels. Or I think it was map, not maps. And then we want to go through and then manually change the names. Okay. Wait, can I do that as a group here? I think I probably can, right? Like that. Or no, that should be... Oh, I messed that one up. It should be a map. Sorry. Let's go right back to that one. That work now? Nope, there's an issue here. Anubis, Ancient, Dust 2, Inferno, Mirage, Nuke, Overpass, Vertigo. Okay, what am I doing that's causing this to be wrong here? Which one's missing? Overpass is missing for some reason. Why? What would cause it? What would cause it to just not work for one out of, but all the rest of them do work? Three, 4, 5, 6, 7, 8. This feels like it should be right. I'm just gonna try to do it one more time just to make sure that that's not what the issue is here. Maybe it's the length here that it just doesn't show, but maybe it is there. I feel like that's also highly possible. But we can see here. Okay. Okay, so we're looking for scatter plots, correlations, box plots, so you can also... I feel like this is like a good basis for this. So maybe we can go through now and then create some different things to make things look nicer, which is also important. So let's do this. Oh, that's another thing I need to change, actually. Hold on. If I go back here. Is there an issue? No. Weird. Okay. Let's go back here. Oh, there's a problem. Oh, sorry. That's because I forgot to put that in. Now it should work. Alright, so then now we can rename these. Okay, so the first one was that. Second one was this. I don't remember if it was final or finals. I think it was final, actually. There we go. Oh, sorry, I forgot that. Let's do that again. That should be good. Now that should be good. Let's see. Yeah, I think it is the text overlapping. How do I make the text labels appear smaller? Is there a way to make the bar chart with legend? I want a legend on it instead in R. Okay. This is if I just do a basic plot. What happens if I try to use the bar plot command? this is just using... So why does that not work? Okay, so we could do... How do we do this? Bar plot. And then our... Does that work? Height is a vector. Wait, is it not a vector? Dude, I do not know enough about this stuff to do this. If I'm adding a legend to a plot... Okay, maybe the problem was just that I messed up with my making a bar plot here. Oh, so... okay, I think this would be the problem. The problem is that if I'm doing just map, then it's just giving me a list. What I would really want is a vector that would give me the count for each. So it'd be something like this. So let's say names function is just a blank string, okay? Sorry, it's just completely null. So then we'll say, or sorry, that should not be a function, that should be a vector. Vector. Okay. For I in levels. What would I say, like... in row... something like that. And then we try names back. Would that work? Oh, I forgot a parenthesis. A parentheses? How do you say one parenthesis? I actually don't know what the correct way to say that one is. Okay, there's an issue here apparently. Oh, sorry. This should be Just a second. Gotta rename some of these. Something like that. So that should work, I think, maybe? Nope. Now it's claiming that this is not a vector either, when it literally is a vector. What? What? Okay, fine. Let's try commenting this out, and then let's return to see what is it we're getting here. Because apparently that's not a vector. What is it then? It's null. Why would it be null? Let's try that. Same thing. Logical 0. I just want to see whether it's even doing a loop. Is it even doing a loop? No. It is. No, it is. Okay. So the problem is this part. Oh. Right? Nope. What am I doing wrong? Oh, man. I don't know what I'm talking about, like, at all with this stuff. Okay. So... quitting... Okay, what's the problem here? Which has to be a logical value? Oh, because that's not. That's a string. I'm sorry, what is it? How does this go? There's like a which is, or how does it go? No, not no, which. Dang it. Basically, I want to say... Okay, so maybe that's not, which is not what I'm looking for, but basically... I want the count. Where it's I, basically. Oh, I think maybe maybe I need a second. Hold on. For JN. Okay, so this is what I do. Dang it. I know there's a way to do this. Ooh, that might be what I'm looking for. So, like this won't do what I'm looking for exactly, because this won't mess with the maps thing. But that's okay. Okay, this does not like. Is not printer for these. Ah, I see. No. Okay, no, that doesn't make sense. What am I doing? Okay, the problem is that I'm trying to use the levels as an index. When really what I should be doing is I should say what is n levels? Okay. Group list, okay. Yeah, it's not what I'm looking for either. Okay, so then levels is also not the function I'm looking for. Basically, I want to find the subset of basically how many. I want to make a vector that says how many of each thing, basically. So for each level, we want to say I guess I could do this one like this. I think I had this. we should... I know that there's a way to do this with like a command that's like 10 times easier, but instead I'm doing this in like the most roundabout possible way with like a bunch of doing a bunch of arrays here. Or sorry, doing a bunch of for loops in order to go step by step through the array. So then we'd do this, and then after that, we'd say that's what we'd do. I think that this should work. This should be what I'm looking for, but it's just an extremely... Yep, there we go. So there's my answer, right? That is just way more annoying than I wanted to do. There has to be a better way to do that, but whatever. So then my answer would be this. Let's see. Does that work? There we go. See? That's what I would want. Exactly. I know that there's a better way to do that, but whatever. Okay. But now that we have this as bar plot, then I can create, I think it's called, so let's go back to the bar plot. We'd say legend. There's something about legend. We have legend text. We can just do legend equals true. Is that... Can you actually do that? Let's see. See, that did not work. Okay. Okay, so I guess I could do this. Okay, so I could say col equals rainbow function that is of length, what is it, 8? Oh, instead of names.arg, what I could do is instead say, I think this should actually instead be legend.text equals that instead. Let's try. There we go. See? That's what I was trying to do. Something like this. Except for the problem now is that this is not the... We would need to now move where the legend is at, is my goal now. So how do I do that? How do I get that to move? Yeah, where can I move it to? So I can either alter the x-axis to make room. I can... Okay. So I could either alter the y-axis. I could pass or I could pass the legend parameters. args.legend. Let's try. Does that work? See, that would, except for now this is messed up in that way. Almost, almost. But I think first I would need to... Oh, I see. So first, in order for that to work, what I need to do is change the, what would you call this? The ylim. So we'd say, what? ylim. And so maybe instead of 70, we say up to 100. Because it looks like 70 is the highest we got. Yeah, there we go. Something like that. Look at that. I actually really like that. I think that looks nice. Although I don't know if these are the colors I'd go for. I probably will adjust them a bit, but for the moment, we'll go with this. Because I think that looks... It's... Or at the very least, it's clear that they're different or whatever. So that is nice. Okay. I'm just going to format this so it doesn't look so cluttered here. But same thing here. And then we could even do some superficial, like, data analysis here, as expected. I think since there we go. Let's get rid of that, so that way this little bit's not visible. I just want to be able to go through each of these and do like the same thing. But yeah. Alright, well, anyways, I think I've been streaming for almost 3 hours. And I need to go get something to eat, so I think that might be it for today's stream. But I thank you for watching. I hope you enjoyed it. I do this daily? I have been for the last few days. I think I'm going to keep doing it. So, if you want to stop by tomorrow, go ahead. But I don't really have like a set schedule. So, if that's your goal, then you can hop on and subscribe. But if not, that's all chill. Anyways, I hope you have a fantastic rest of your day. And if you're studying, I hope you do well on whatever you're studying for. So, thanks. Have a good one. Peace.